called solving rational equations. And the target. What are the steps to solving rational equations? Easy enough. What's that? I cannot hear you. Oh, pretty long. Pretty long. How do you determine if your solution is extraneous? Example 1. All right, so solving rational equations. So equation obviously has an equal sign in it. Rational means in simplest form you have a fraction, okay? So I know y'all love the fractions, right? The first one we're gonna do, y'all might be like, what? Oh my God, I'm never gonna figure that out. I'm just not gonna do it. Just stick with me. If we do a couple of them, then it's gonna start making a little more sense. It's gonna get easier to you. You just throw your hands in the air, wave them around like you just don't care. It's not gonna be easier. This is not the easiest topic that there is, especially if you don't pay attention and ask questions when you don't understand, okay? So pay attention. So we're gonna solve 6 divided by x plus 3 equals 4 divided by x minus 3. First thing we're going to do is factor the denominator wherever possible. So if any of your fractions have a denominator that can be factored, you want to start by doing that. If they can't, you move on to the next step, okay? We know how to factor. We know what can and cannot be factored. So, and it doesn't matter the numerator. If the numerator can be factored at this point, we don't worry about that. It's just the denominator, okay? So, first fraction, x plus 3 is the denominator. Can x plus 3 be factored? Which one? Okay, how many degrees does it have? Degrees. 1 degree, right? X is x1 is a 1, which we call that a linear function or a linear expression. The only way to factor a linear expression is if it has a greatest common factor. If it was a quadratic, we could maybe do teacher aren't dividing slide, right? If it had 3 degrees, maybe we could do factor by grouping, or it might be a sum of cubes or a difference of cubes, or it might have a GCF. But this is just linear. Does it have a GCF? No, it can't be factored, nothing we can do. How about x minus 3? Can it be factored? No, okay, well, good. I like that. Next step, multiply each term by the LCD. What is LCD? Least common denominator. I have 2 fractions. One of the fractions has a denominator of x plus 3. The other fraction has a denominator of x minus 3. Any idea what my least common denominator would be? And you got it. My least common denominator, I need one of each factor. One of my factors is x plus 3. The other factor is x minus 3. What I'm trying to do here is I'm trying to get the fractions to go away. I'm trying to clear the fractions, okay? So let me rewrite this problem, give myself some room. I don't want to squeeze everything in there. I'm going to bring down 6 divided by x plus 3 equals 4 divided by x minus 3. Give myself some space. So each of those terms, a fraction is like considered one term, okay? Each of those terms will be multiplied by x plus 3 times x minus 3. So this first fraction, this first term, let's multiply it by x plus 3 times x minus 3. So when I multiply, think about that as like, this is all in the numerator. X plus 3, x minus 3 times 6, that's all in the numerator. 1 times x plus 3 is in the denominator. Are there any factors that are identical in the numerator and denominator that I could cancel? Yeah, x plus 3 divided by x plus 3 is 1. Okay, we have to multiply this other term by the least common denominator. So we're going to multiply it by x plus 3 times x minus 3. So think about that as just being all in one fraction. When I multiply, it's times the numerator. Do I have any factors that are identical that I can cancel? Right. X minus 3 divided by x minus 3 is 1. At this point, you shouldn't have anything left in the denominator except for 1. If you have something besides 1, say you just chose x plus 3. Well, that would have canceled this x plus 3, but when you got over here, x plus 3 over x minus 3 wouldn't cancel. So you would still have that x minus 3 in the denominator, right? Your goal, when you choose the least common denominator, you're wanting everything to cancel, okay? Julio? So now, step 3, rewrite the equation. So I want to rewrite it so that all that canceled stuff is not there. Y'all down with that? All right. So in my first fraction, all I'm left with is x minus 3 times 6 over 1. We don't need that 1. So I can either put x minus 3 times 6, or since that 6 is by itself, I'd probably put that out front and multiply that in parentheses by x minus 3. Because it's not just 6 times x, it's 6 times x and negative 3. On the right side, everything canceled except for 2 factors, x plus 3 and 4. And whatever's left in the numerator, I got to multiply together, okay? So since that 4 is a single term, a monomial, I'm going to put it first. And then the binomial, I'll put together. At this point, does this look way less complicated than it was before? We got rid of the fractions, right? Could y'all solve that equation without me? I would hope so. So step 4, we're going to solve for x. And that's going to look different in every problem. It just depends on what you have left. So first of all, what should I do? Simplify. How am I going to simplify? How am I going to get rid of the parentheses? What? All right, so distribute, right? 6 times x and 6 times negative 3, and I'll do the same thing to the 4 times x and 4 times positive 3. So 6 times x gives me 6x, and 6 times negative 3, negative 18. Bring down your equal sign, make sure everything's lined up. 4 times x is, and a lot of people forget to distribute to all the terms. They'll just say it's 4x plus 3. Is that okay? It's 4x plus 12. I do. Do I have any like terms on the left side that I could combine together? No. Do I have any like terms on the right side I could combine together? No. 4x and 12 can't be combined. 6x and negative 18 can't be combined. So if I did, I would combine those first before moving things from one side of the equal sign to the other, okay? But no like terms on the left side, no like terms on the right side. So let's get our x's together. Usually you don't want to get your x's together. It's a bad idea. But in algebra, we like to get our x's together. Thank you. Somebody thought I was funny. Thank you. All right, so there's 4 different things I could do here. I could subtract 6x from both sides. I could add 18 to both sides. I could subtract 4x. I could subtract 12. Me personally, I usually like to start with getting my x's together and positive if possible. So if that's my goal for during this next step, what would I do next? Subtract 4x from both sides. If I want to move it from the right side to the left side, if I said plus 4x, what's 4x plus 4x? 8x, I doubled it, right? I want it to go away, so I had to subtract it. So on the left side, my like terms, I lined them up. 6x minus 4x is 2x. Bring down that minus 18. There's no like terms to combine it with. Bring down your equal sign. We already said 4x minus 4x is 0. I do not need to write 0 plus 12, just plus 12. I do. All right, negative 18 and positive 18 cancel. All we're left with is 2x equals 30. Now, I notice a lot of you when you're solving equations, you don't bring the equal sign down. It's just like you just stop writing it at some point. And it's like it's one big expression. Don't do that. You got to bring the equal sign down. Keep it lined up. Yes, sir. Am I finished? Have I solved for x? Divide by 2. And my answer is 15. Maybe it might be extraneous. Yeah. Y'all ever heard of that? Extraneous. Have you ever heard of an excluded value? Yeah. Or a restriction. Or an exclusion. They all mean the same thing. So, y'all had to have heard of extraneous before. Yes, you started learning about that in middle school. So listen to me. The target said, how do you tell if your solution is extraneous? An extraneous solution means we have an answer and we got it correctly, like we didn't make any mistakes. But if I actually plug that answer back into the problem, simplify the left side, simplify the right side, they actually won't make a true statement. That's what extraneous means. So I can either plug it back in and see if I make a true statement or not, or there's a shorter way, okay? So what we're gonna do is find the restrictions. Restrictions are also called excluded values or exemptions. And that's important to know because sometimes I write it differently. Like I just, whatever comes to mind, they all mean the same thing. It's like roots means zeros, means solutions, means x-intercepts, right? So any value of x that would give you a 0 in the denominator is going to be an excluded value, okay? It can happen. You can't have x, you can't have 0 in the denominator. If you have 0 in the denominator, is that okay? What do you get when you simplify a fraction that has 0 in the denominator? Undefined, undefined, right? 0 in the numerator simplifies to just equal 0, unless it's 0 divided by 0. You can't do that. The 0 divided by anything else simplifies to be 0. But if 0 is in the denominator, we call that undefined. So a restriction is any value of x that's going to give you 0 in the denominator. So easiest way to do it, go back up to both of our factors. Denominators were already factored. We didn't have to do anything. But if it's not, go to the part where it's factored before you cancel anything. Look at x plus 3. What would I have to substitute for x to add 3 to it to get 0? Negative 3. Negative 3 plus 3 is 0. So x cannot equal negative 3. Look at this factor. What would x have to be if I subtract a 3 from it to give you 0? Positive 3. So my excluded values, x cannot equal positive or negative 3. Did x equal positive or negative 3? No, it was 15. So if it did, say I solved and x was 3, well, that's called an extraneous solution. Mathematically, it worked out, but if we plugged it in, it would give us 0 in the denominator. That's what an excluded, or that's what a extraneous solution is, okay? But as long as our answer is not positive 3 or negative 3, we're good to go, as long as we did it correctly. So let me just write that down. Y'all know you get to use your notes on the quiz, right? So every little thing helps. Restrictions are solutions that would give you a 0 in the denominator resulting in an extraneous solution. Extraneous solution. Some kids get confused how to find x. If the coefficient of, or your restriction, if the coefficient of x is 1, soup's easy, you can just look at it and tell, right? But say you had like 2x plus 1. Well, then what would it be? So if you get confused on how to find your restriction, all you do, so my first factor was x plus 3. I want to set it equal to 0 because I want to know what does x have to equal to give me 0. Well, if I subtract 3 from both sides, if x is negative 3 plus 3 will give me a 0, right? So that's how I came up with the negative 3. My other factor in the denominator was x minus 3. Set it equal to 0. Solve for x. X equals 3. So for the factor x minus 3, if x is 3, 3 minus 3 is going to give me 0. Can't have that. So if you can't look at it and tell, because a lot of kids, you know, next week will be like, I have no idea how you find the restrictions. Like, I just don't get it. That's all I'm doing. Set it equal to 0, solve for x. Whatever value you get is going to be your excluded value. If your answer is one of the excluded values, you can't call it an answer. You have to call it an extraneous solution. What? So like say I got right here x equals 3, and I said, oh, that's a restricted value. Then I couldn't tell you my answer is x equals 3. I can say x and put a line through the equal sign, like not equal to 3, but you really should say extraneous solution, okay? That means it was an answer, but it doesn't actually work, so it's not actually the answer. There's not one. There's not a real number that will work in this problem, okay? Don't worry, we'll do more. Yes. Okay. Because I want to solve for x. So if I subtracted 12, I could do that. But then I would have 0 over here. And on this side, I would have 2x minus 6 equals 0. And then I'd have to move the 6 over, or I just did my math wrong. It would just be an extra step. Because I'm trying to get x by itself. So I wanted to move the 18 away from the, huh? Yeah, if you would. So say right here, 2x minus 18 equals 12. So you said, why can't we just subtract 12? All right, so we get 0, and then we get 2x minus 30, right? We still got to solve for x. So now we're going to move that 30 over to the other side. 2x equals 30 divided by 2, x equals 15. So you'll get the same answer, just an extra step. I want to move everything away from x. Any other questions? Okay, example 2. Well, we won't, 6, I think. X minus 1 divided by x plus 3 equals x minus 1 divided by x plus 3x minus 12, right? Divided by x squared plus 3x. Last time there was only 2 fractions, now there's 3 fractions. It's okay, we still do the same thing. Step 1, factor any/all denominators. In the last example, I had 2 fractions. The denominators of neither could be factored. They were already factored, right? But that's not always the case. So let's look at my first fraction. The denominator is x plus 3. Can that be factored? No, it's linear. Unless it has a GCF, can't be factored. The second fraction has a denominator of x. Can I factor that? No. Any monomial, even if it could be factored, like say it was x squared, well, that factors to x times x, but a monomial you don't need to factor. Look at my third fraction. Can that be factored? Well, it's a quadratic, and it also has a greatest common factor. So I can at least factor out the GCF, and then if I can factor further after that, then I will. What is the GCF? X. So I'm going to factor out the x. Remember when I taught y'all how to do factor by grouping and we had to factor out the GCF all the time? So we should be used to this. So to see what's left, divide each term by the GCF. What's x squared divided by x? X. Positive 3x divided by x. Positive 3. Now, do I still have a quadratic inside my parentheses? No, because x as high as 3 is 1, right? If that was a quadratic, maybe I could factor it further, but it's just linear and there's no GCF, so I factored completely. That wasn't too bad. So I'm going to rewrite my problem, but I'm going to give myself some space in between each fraction so I don't have to jumble it all together when I go to multiply by my LCD, okay? And I'm going to rewrite this fraction with the denominator in factored form. So my first fraction, x minus 1 divided by x plus 3. Equal sign, bring it down. I'm going to give myself some space so I can come in and do that LCD. And then it says to add the next fraction. And I'm going to give myself some space. That numerator, yeah, I can factor that, but no need to. It's the denominator that we need to worry about. So the factored form of the denominator was x times the quantity of x plus 3. All right, let's figure out what that LCD is. I'm telling you, this is the hardest part for kids, okay? This first fraction has a factor of x plus 3. Those two terms go together. That's not two separate factors. We know a binomial goes together, right? So I've got a factor of x plus 3. I've got a factor of x. The last one, I have an x and x plus 3. I only need to include one of each factor unless I have two of the same factor in the same fraction. Okay, so somebody give me one of the factors of my least common denominator. X. Give me the other one. X plus 3. If I just said, oh, it's x plus 3 because x plus 3 has an x. But can x plus 3, if you divide by x, those won't cancel, right? Because the binomial is all or nothing. So I'm going to multiply each term times x plus 3. If I want to put those binomials in parentheses, I can. Everybody cool with that? In my first fraction, do I have any factors that will cancel? X plus 3 divided by x plus 3 is 1. In the second fraction, is there anything that will cancel? X divided by X is 1. That's one big fraction. In my last fraction, X and X plus 3. We like that. Am I left with anything in the denominator besides a 1? Okay. So again, if I would have said, oh, my least common denominator is X plus 3, well, this would have canceled, this would not have canceled, and this X would not have canceled. So we would still have something in our denominator that we had to get rid of, right? All right. So now we go through each fraction, and let's rewrite what's left. So my first fraction, I've got an X times X minus 1. Bring down your equal sign. In the next fraction, I have X plus 3 times X minus 1. I have two binomials. And then I'm adding, I do whatever the problem said, whatever those signs are, I'm adding. The last term, everything canceled except for 3X minus 12. Now there's still a lot to do here, but at least we don't have a fraction, am I right? We cleared the fraction. Now before I can start combining like terms and all that stuff, I have to get rid of the parentheses. There's nothing to simplify inside the parentheses. So I'm gonna have to do some distributing, right? So let's look on the left side. I'm gonna distribute. What is X times X? X squared. What's X times negative 1? Positive or negative? Negative 1X. And I mean, you don't have to put negative 1, but a lot of times when y'all combine like terms, if there's not a 1 there, we forget. Now to distribute over here, I have a binomial times a binomial. So there's a little bit more distributing going on than there was over here. So be careful. X times X is X squared. Now we got to distribute to the negative 1. X times negative 1. Anybody? Negative 1X. Now I'm going to distribute the 3. Positive 3 times positive X. Positive 3X. And positive 3 times negative 1. Negative 1. Now, the plus 3X minus 12, I'm just bringing that down. It was not in parentheses. Nothing I can do with that. Now, before I can go moving stuff over to the left and to the right of the equal sign, if there's any like terms on the left side, combine them. If there's any like terms on the right side, combine them. On my left side, do I have any like terms? No, because this is squared and this is to the first power, right? So those aren't like terms. Do I on the right side? Yeah. So we need to combine like terms before we go moving things from one side to the other. So the left side, I'm just going to bring that down. X squared minus 1X equals. So let's go ahead and write it in standard form while we're at it. What's the term with the highest degrees, or what is our highest degree? X squared. And are there any other terms that have a X squared? No, so there's no like terms to combine X squared with, right? My next highest degree will be X to the first power, my linear terms, and I've got 3 of those. Negative 1X, positive 3X, and positive 3X. So we're adding or subtracting. What's negative 1 plus 3? What's 2 plus 3? And is that positive or negative? So that would be positive 5X. Then I come to 0 degrees, which are constants. Those are numbers without variables, right? I've got 2 constants. Those are like terms. What is negative 1 minus 12? Negative 13, but something's not right somewhere. Oh, why don't y'all tell me? Right here, 3 times negative 1 is negative 1. Oh, what should that have been? Negative 3, oopsie. So that's going to make a difference, right? Negative 3 minus 12 is negative 15. All right, so do you notice I have an X squared on the left and X squared on the right? So if I move one to the right side or the one on the right to the left side, they're going to cancel each other out, right? Because if I subtract x squared to move this over to the right, when I move it over to the right, well, that's going to cancel too. Sometimes that happens. That's cool. So let's see, I have left negative 1x equals 5x minus 15. I'm trying to solve for x. What should I do? Okay. So I can move this negative 1x over to be with the 5x, or I can move the 5x over to the left. Either way, it's the same thing, but one's going to cause us an extra step. What do y'all want to do? Okay, if we do that, we're going to have 0 over here, and then we're going to have to move something back, which is fine. So, okay, I'll do that. Subtract the 5x. I don't normally like my x's to be negative, but it's okay, we can fix it. So what is negative 1x minus 5x? Negative 6x, good. Bring down your equal sign. 5x minus 5x is 0. Bring down your negative 15. Have I solved for x? Close. What do I do now? You know it. Negative 6x divided by negative 6 is positive x equals, okay, right here. What's a negative divided by a negative? Positive. Does 15 divide by 6 evenly? No. So 15 sixths, can I reduce that? What divides into 15 and 6 evenly? 3 divides into 15 5 times, 3 divides into 6 2 times. So 15 sixths is okay, but at least reduce it. So I prefer either 5/2 or mixed number. 2 goes into 5 how many whole times? How many is left over? Over. Or in decimal form, what would that be? 2.5. You get to that point, I will be so happy. Okay, well, we think 2.5 is the answer, but what if it's a restricted value? No, girl, we were solving the equation. We have not found the excluded values yet, but that's the easy part. So go back up to where your denominator was factored. Let's look at this factor. And if you don't have any variables in the denominator, there's no excluded values. But if you have a variable in the denominator, then you're going to have excluded values. So for x plus 3, what would your excluded value be? Negative 3, because negative 3 plus 3 is 0, right? So x cannot equal negative 3. What about for that second fraction where it was just an x? X can't equal 0. Any other number you plug in for x is fine, right? What number would you plug in for x to make it a 0? Could I plug in a 5 and make it a 0? A 25? A 1 billion? A zillion million? What if it was a 0? Then I'd get a 0, right? So if it's just an x by itself, or even 2x, because 2 times 0 is 0. All right, and then that last fraction, this x is a 0. We already said that. This one would be a negative 3. We already said that. So our excluded values are negative 3 and 0. Was our answer either of those? No. So our answer, as long as we did it correctly, is good. If our answer was one of these two, we would say it's extraneous. There's not actually a real solution. Right on. Crouton. So I told you 5, but I'm going to do 2 more and call it a day. Unless you want to do 6. I have 6 ready to roll. All right. Example 3. One divided by x minus 1 plus 1 divided by x plus 1 equals 2 divided by x squared minus 1. No. What's really no fun is when they all can be factored. Whew. Second fraction, can x plus 1 be factored? No. How about x squared minus 1? Well, it's a quadratic, so it might be able to be factored. If it can, we got to do it. Is there a GCF? No. Okay. Now, this is actually a difference of squares. It's a perfect square minus a perfect square. We've factored those before. But if you don't remember how, you can do your T-chart divide and slide. What would A equal? 1. What is B? Oh, 0, because B is your linear term, the coefficient, right? What is C? -1. So to factor, you need two numbers that multiply together to give you A times C, which in this case, A times C is -1. And on the right side, you want two numbers that add together to give you B, which is 0. All right, let's see. +1 times -1 is -1. What's 1 plus -1? 0. Boom. So my factors will be x plus 1 and x minus 1. If we would have remembered this is a difference of squares, recall that there's an identity that goes with that, meaning you factor it the exact same way every time. You make two sets of parentheses. One gets a plus in the middle, one gets a minus in the middle. The first term of each group is the square root of the first term. What's the square root of the first term? X. The second term of each is the square root of the second term. Don't mind the negative. What's the square root of 1? Boom. Either way. So I'm going to rewrite this, and I'm going to rewrite this fraction in factored form, the denominator, and I'm going to space it out. So I have enough room for the LCD. So 1 divided by x minus 1 plus, give me some space, 1 divided by x plus 1 equals, give me some space, 2 divided by x plus 1 times x minus 1. Have we determined our LCD? Can anybody give me one factor of our least common denominator? Not just an x. None of them are x by itself. An x plus 1, is that the only common denominator? X minus 1. All right. Any others? Well, if something doesn't cancel out, we know we missed something, right? So I'm going to multiply each term by x plus 1 and x minus 1. In my first fraction, do I have any factors that will cancel? X minus 1. Anything else? Well, I already canceled out the only denominator, so no. And the second fraction, anything will cancel? X plus 1. My denominator is now 1. Boom. And the last fraction, x plus 1 and x minus 1. So every single fraction, the denominator turned into a 1. That's what we wanted. We wanted to clear the fractions, yes? Okay. So now let's go back and rewrite each term without all the stuff we canceled. What's left? So my first one, I have x plus 1 times 1. Well, isn't that just x plus 1? Okay, so that's all I need from there. Then in between those two fractions was this plus sign. Bring that down. A lot of kids don't do that. Like they don't bring down the pluses and the equal signs. You have to do that. You're gonna be really confused. And the next fraction, I have x minus 1 times 1, which again is just x minus 1. I don't need to put the parentheses because when I multiply by 1, I know what I'm gonna get. Then bring down the equal sign. All I have left over here is 2. Okay, before I start moving stuff around, on the left side, do I have any like terms that I can combine? Yeah. So what's the highest degree of any of those terms? 1. X is to the first, X is to the first. So those are like terms, right? What is X plus X? No, X times X is X squared. 2X. Remember, you just add the coefficient. 1 plus 1 is 2. Bring along the X. All right. Plus 1 and minus 1, those are constants. What do you get when you add 1 and subtract 1? 0. Do I need to put 2x plus 0? No. And that equals 2. Is that my answer? No. What do I have to do? Divide by 2. 2x divided by 2 is x, equals 2 divided by 2 is 1. We think that's our answer, but if you forget to check for restrictions and that's a restriction and you tell me that's your answer, you just got the whole problem wrong. So don't forget that. Restrictions, excluded values. That's what x cannot equal. If it does, it's extraneous. So let's go back up here to where we factored our denominators. So in this first factor, what would x have to be to give me 0 there? 1. So excluded value of 1. What about for x plus 1? -1. And then these two would be +1, -1, same thing, right? Well, is my answer an excluded value? So is that actually my answer? No, it's not. And if you tell me it is, you're wrong. Now, I wouldn't like mark the whole thing wrong. You did everything right beautifully, but you forgot to check for the excluded values. I would give you points for sure, but not all of them because it's really not the answer. So x equals 1, that's not true. So this is an extraneous solution because 1 is an excluded value. So this problem has no real solution. I'm going to do one more. So the good news is I'm not giving you practice problems tonight, and we're not going to have a quiz at the beginning of next class because I want to do several more examples with you because this is just one of those concepts that every problem's different. They're not the same at all, and I want to do more. So I'm not giving you practice problems today. We won't have a quiz at the beginning of next class. However, probably next class we'll have time at the end to work on practice problems for this. So if you didn't take the quiz today, today's quiz, you need to be ready to do that on Monday. So make sure you get your notes and whatever so you can take that. Or if you want to do a retake, that would be a good time to do it. Okay. All right. So example 4. Does that mean you stop and take a nap now? Because you know you don't have a quiz on Monday? No, it doesn't. What if I gave you this exact problem on your quiz, but you took a nap, so you don't have it in your notes? And you can't figure out how to do it on your own. So on both of these, the denominators in each fraction are a monomial. You don't have to factor a monomial. And the great thing is they're the exact same. So this one's much easier when it comes to this part. What is your least common denominator? 2x. Easy. So I'm going to multiply both sides by 2x. On the left side, 2x cancels. On the right side, 2x cancels. Loving it. Anybody confused? All right, let me write what's left. So I have on the left side of the equation x squared minus 14. Bring down your equal sign. On the right side, I have 5x. Who are my seniors? Anybody going to college next year? Yes? Okay. When you take that entrance exam, if you're in Florida, probably the PERT, if you can do these problems and get them right, you're going to do very well on the PERT. Very well. This whole section that we're doing now and the last one, I would definitely be reviewing that before you take the PERT, either if you're taking it now to do dual enrollment or when you go off to college. You'll do really good. Okay. All right. So if I subtract 5x from both sides, is it going to cancel anything out? It won't, except for the 5x, but it won't cancel anything over here, right? If I subtract x squared from both sides, will it cancel anything? Can I just solve for x? Okay, I can. And then I'll have x squared equals 5x plus 14. And then what? And then I'll have, like, nothing's going to go away. You know what I'm saying? I can't just solve for x. Nothing's going to go away. You know this because I have two terms with x in it, one that's squared and one that's to the first power. So I can't combine them. They're not like terms. Well, I can subtract 5x. And on the right side, 5x minus 5x is 0. On the left side, are any of those terms like terms? No. Okay, I've got three terms. They're not like terms. Let's write it in standard form. Which term should come first? X squared. Then what? Minus 5x. And then negative 14. Y'all know that when you have a quadratic, you can't just solve for x by moving everything to the other side of the equation, right? You either have to solve it by factoring. Does factoring always work? No. Quadratic formula, does that always work? Yes. Completing the square, does that always work? Yes. So if we're going to solve it, which that's what the directions say to solve, we can factor, quadratic formula, or completing the square. I'm going to try to factor and hope that works. Do we have a GCF? No. Okay. What is A equal to? 1. What is B equal to? Negative 5. What is C equal to? Negative 14. So make my little T-chart. On the left, I need two numbers that multiply together to give me A times C. What is A times C? Negative 14. And on the right side, I want the same two numbers to add to give me B, which in this case is negative 5. Say it again. Negative 7, positive 2? Is that what you said? Oh, positive 7 and negative 2? That multiplies to give me negative 14, but it's going to add to give me positive 5. So, okay, let's try negative 7 and positive 2. Still multiply to give me negative 14, but negative 7 plus 2 gives me negative 5. So that's what I'm going to use, the negative 7 and positive 2, right on? So let's make our parentheses. The first term in each set is whatever variable we're using. In this case, is an x. The second term comes from the T-chart. We need a negative 7 and a plus 2. Will I be dividing and sliding? Not necessary because A is equal to 1, right? So those are my factors. My factors are x minus 7 and x plus 2. What have I solved? Do we know how to solve once we factored? You know it. Set each factor equal to 0. Remember when we did this, when we just graphed those 3 different methods and every time we factored, we set it equal to 0? But if it had a quadratic term and a linear term, we couldn't do that. We had to factor first and then do that. So one of my solutions is positive 7. My other solution is negative 2. We think, right? But have we found our restricted values? Let's do that. What can x not equal? Go to your denominators. 2 times what would give me 0? A lot of kids say -2. Is 2 times -2 0? No. Okay, what's 2 times 0? So x cannot equal 0. Is there any other number I could plug in for x, multiply it by 2 and get a 0? No. Are either of my answers 0? So my answers, as long as I did it correctly, I get 2 answers. Right on? So next class, we'll continue on examples. I'm not giving you any practice problems today. At the end, when I do give you practice problems on it, if you need to make up today's quiz or retake today's quiz, that will be the time to do it. Be ready.